Ever get confused by color temperature and all the advice about warm and cool colors in painting? Well, here is a question from Trisha, a viewer from Florida. When we paint in oils or any medium, I guess, what temperature are the highlights and what temperature are the shadows? One famous YouTube artist says all highlights are cool and all shadows are warm. Other artists claim highlights are warm and shadows are cool. Some say it depends. Do you have any content that does a deep dive into the actual science and applications of temperature color theory? I love this question, and yes, I can absolutely go on a deep dive and discuss what's going on here. The truth is, in this debate, neither group is flat out wrong. What's happening is that genuine observations about light and context are getting flattened into a general rule. And when you flatten a context-dependent observation into a rule, you lose the context. So let's put the context back. First, I want to mention that color temperature itself, the term, the concept, can mislead us if we treat it as a fundamental property of color. Color temperature is not one of the three primary dimensions of color perception. Those are hue, lightness, and chroma. Rather, temperature, in the way painters use it, is a description of systematic hue and chroma shifts that we perceive in specific contexts.
You could visualize it this way. If I'm looking at this gray dot, it might seem like a cool gray in this palette, but if I shift the palette, the context of the colors around it, now that same gray might seem warm.
So while many of us learn that this is a cool red and this is a warm red, outside of any context, not knowing the scene or the lighting or what the surrounding colors are, these two reds are actually better described as differing in hue than as differing in temperature. This one's not cooler, it's purpler, and this one's not warmer, it's oranger. Again, temperature is contextual. A color can look warm or cool relative to something else, relative to the colors around it, or relative to the light source it's being seen under, or both of those factors at the same time. That contextual nature is exactly why two smart, experienced painters can look at the same subject and come away with different rules.
All right, let me show you something I painted specifically to explore this issue. Same subject, a garlic bulb and a potato, but once under a warm light source and once under a cool one. And in both cases, I used only one light, no fill light or backlight or ambient light. So look at the shadow areas in both paintings. I just painted what I observed. And there's no opposite temperature in the shadows. There's no cool here and there's no warm here because there's no second light source to create it. This is the key, I think, to understanding the whole debate. The warm highlights, cool shadows rule doesn't come from a warm light source alone. It comes from having two light sources of different temperatures hitting the same subject at the same time. Ta-da! You take away the second light source, you take away the temperature contrast. The rule doesn't apply not because it's wrong, but because the condition that generates it isn't present. Now it is, now it isn't. So outdoors in daylight, your subject is almost always being lit by two light sources simultaneously. There's the dominant light source, the sun, which is doing most of the work on the lit surfaces. Direct sunlight, when the sun is low in the sky, is warm. It's skewed toward the longer wavelengths, the oranges and yellows and reds, but that's especially in the morning and evening. Photographers call that the golden hour. But the sun isn't the only light hitting your subject. The sky itself is also a light source. Scattered light from the atmosphere comes in from all directions, reaching into the shadow areas that the sun can't touch. That scattered light is cool because it's skewed to the shorter wavelengths, the blues and blue violets being scattered by the sky.
Now, why does the other camp say warm shadows, cool highlights? My hunch is they might be getting fooled by simultaneous contrast. And that's the other part of context that we so often interpret through the framework of warm and cool.
Here's a great example. Look at the veins showing through my skin here. They look sort of blue, right? But if I take a digital photo, zoom in, and sample those pixels, they simply aren't blue. They're desaturated, as same hue family as the rest of my skin, just lower in chroma. But because they're surrounded by more saturated, warmer skin tones, our eye pushes them toward the opposite, toward blue.
Now apply that to a painting. When your subject is brightly lit and the shadow areas are dark and relatively low in chroma, the shadows don't even need a cool fill light to look cool. The warm, vivid lit areas are doing the pushing. Simultaneous contrast is nudging those duller shadow passages toward the opposite of warm, and the painter reads that as cool shadows. Flip it around, a painter who's working from a cool, overcast light source might find that the subtly warmer, lower chroma shadow passages appear warm by contrast with the cool lit areas. So experienced painters who describe warm shadows and cool highlights aren't making things up, but they are probably overgeneralizing a specific perception context.
So I set up a still life with two light sources, a warm one coming in on this side and a cool one coming in on this side. It's on the warm side, you see them shifting toward orange, and on the cool side, you see them shifting toward a blue or blue-violet. And that's temperature contrast in its most obvious form. Now look at the green jug here. On the warm side, under the warm light source, it shifts yellow-green, and the warm light is adding long wavelength energy, light reflecting off the jug, which pushes the perceived hue toward yellow. And on the cooler side, it stays closer to its local color, or maybe shifts slightly toward a blue-green. And then there's this little area here, where the warm and cool lights overlap. You might expect that to look neutral, like the warm and light would sort of average and cancel out, but what actually happens here is it looks slightly pink.
Why? Because these two lights are mixing additively. The warm light has a spectral slope weighted toward the long wavelengths, the reds and oranges, and the cool light is weighted toward the short wavelengths, the blues and violets. So when those two spectral slopes add together, the middle wavelengths, the greens, are relatively underrepresented in the combined light, and so what you do perceive when your long wavelengths and short wavelengths cone cells are stimulated, but your middle wavelength cone cells aren't getting much signal, is magenta or pink. It's the same reason red light and blue light mix to magenta on an additive color wheel.
Once you know what to look for, you start seeing this in careful observational paintings throughout history. Here's a detail from a work by Cecilia Beau, Twilight Confidences from 1888. And right here, in the zones where two differently temperature light sources meet, you can see that same warm-cool overlap resolving into subtle pinks. If you look closely, you'll find similar passages in paintings by Monet, Joaquin Sorolla, and others.
So when does the rule break down entirely? When both light sources are close to the same temperature, there's very little hue shift between light and shadow at all. And when your fill light isn't the cool blue sky, but instead a colored bounce, a green lawn reflecting up into the shadows, or a red wall filling in the shadow side of a face, then the shadow temperature depends entirely on that specific reflected color. It might be warm, cool, green, orange. So rather than following some abstract rule about color temperature, maybe just be observant. So to sum up, here's my answer for Trisha and anyone who's been caught in this debate. The warm highlights, cool shadows rule is a real observation about a very real and very common lighting situation, outdoor daylight, where a warm dominant source and a cool ambient fill are working together. It's a consequence of a specific relationship between two light sources that we encounter often. When you understand why it works, you can also understand when it doesn't, and you can start to see your actual lighting situation clearly enough to paint what's really there, rather than painting according to a rule that tells you what should be there. And also keep simultaneous contrast in mind, because sometimes what looks like a warm shadow is just a dull color sitting next to a vivid one getting pushed perceptually. Trisha, thank you again for writing in. This is exactly the kind of color theory question that deserves more than a quick, glib answer. And if anyone else has a good color theory question, hit me up. Thanks again, and see you around.